have a to the q over a r times a to the s. You can write this two different ways, and if you're unsure, I would suggest that you plug in a number. Maybe we say q is 10, and r is 2, and s is 3. These are on the denominator. They have like bases. We know we need to add them. And then this is dividing, so we know that we need to subtract. So ultimately, we would have 10 minus 2 plus 3. And that's how you can, which would be a to the fifth, but we're not needing to do that. So you can write q minus parentheses r plus s. You have to have these parentheses. Otherwise, you're saying q minus r plus s, which is a different order of operations. You could also write this as q minus r and then minus s. So these are two ways that you can write this. If we go back to our number version, again, 10 minus 2 plus 3, we know we need to get 5, but this is 8 plus 3 is 11, so that's not going to work. But if we said 10 minus 2, we get 8, minus 3, we get our 5 that way. So these are two different notations. Make sure that if you're going to use a plus, you have that parentheses. Okay, you're not going to be able to use your flower foldy or your radical foldy on your test. However, all of these exponent rules are on your formula chart. Okay, I'm going to make this a to the 1. We know when we divide that we have to subtract. We can get a to the second, b to the negative 3, and that's a fine way to write this. However, if they say you need to write it with positive exponents, you need to be able to also simplify a squared over b to the third. Okay, so technically both of these are correct. It depends on what the answers are, and it will be a multiple choice test. Sequences, it's a blast from the past. You need to remember when we do sequences that we are actually starting with 1, not 0. And you are looking for a pattern. So this is times negative 3. So since we're timesing, again, that means that this is a geometric sequence. So we need a sub 1, which happens to be 2. And then we write our recursive a sub n, our r, this is our r value, our common ratio, negative 3 to the n minus 1. You could then take that and write an explicit if you needed to. Number 4 is talking about area. We know that area of a rectangle is length times width, and they're telling us the area is 24 x to the 7th, y to the 5th. And they're telling us that the width is 6x to the 3rd, y squared, and we need to find the length. Well, we know when we solve an equation, this is multiplying, the inverse is to divide. We have L equals 24 divided by 6 is 4, and we're going to subtract these just like we did on number 2. So x to the 4th, 5 minus 2 is 3. So make sure when you're looking at your coefficients, remember you're doing whatever operation it tells you to do. You're not going to subtract those. Okay? 3 different ways to write c to the 5th over c to the 12th. Well, we know when we are dividing, we need to subtract. So we could write c to the 5 minus 12, which we know is c to the negative 7, which we can write with a positive exponent of 1 over c to the 7th. Number 6 is probably the hardest question on this whole paper. Anything to the 0 power is 1. You could even put that in your calculator if you really wanted to. You will get to use your calculator, so if you needed to check any of this math, you could. Write the equivalent expression. Okay, we're multiplying here, so that means we're going to multiply our coefficient. 7 times 3 is 21. I'm going to put a 1 with my b's, and we're going to add our exponent. We can say a to the 4 plus 3, b to the 1 plus 1, 21, a to the 7, b squared. Hopefully you're doing good. Volume. We had had a question like this on one of our homework. Volume is side cubed. So I need to take this and I need to cube the whole thing, which means I'm going to have to distribute that 3. So I can write 3 cubed. 2 times 3 is 6. 1 times 3 is 3. And I would take 3 cubed, a to the 6th, b to the 3rd. Or I know that 3 to the 3rd is 27. A to the 6th, b to the 3rd. I would take either of these answers. Square root of 72, I think we've done this about 5 times now, right? You just have to do your factor tree. So we say 2 and 36, 2 and 18, 2 and 9, 3 and 3. Again, it's a square root, so we're looking for pairs. Pairs are going to go outside. Remember, we are always multiplying when we do this. Singletons go in. 2 times 3 is 6 times the square root of 2. Make sure that your pairs become your coefficients and they go outside. On the back, here we have another awesome, fabulous sequence. I'm going to make a table, 1, 2, 3, and 4. Is this geometric or arithmetic? Remember, this is multiply, divide. This is add, subtract. So if I'm adding, that's plus 6, so that it doesn't work here. So this has to be a geometric sequence of times 4. Geometrics have common ratios. Arithmetics have common differences. And my common ratio is 4. If we wanted to take this a step further and actually write that as an explicit, remember a sub n is equal to a sub 1 times r to the n minus 1 power. So we could write this as 2 times 4 to the n minus 1 if they wanted us to write a formula. Simplify. Square root of 50 is 2 and 25, which is 5 and 5. Some of you on your quiz were forgetting your coefficient that was already outside. This is 2 times the 5 on the square root of 2. Square root of 8, I do believe most of you have memorized. 2 on the square root of 2. Because our radicands match, we can subtract our coefficients. We're going to simplify this to 10. 10 minus 2 is 8 on the square root of 2. And this is one that you can put into the calculator to double check if you wanted. Write an equivalent expression. This is multiplying, guys. This is going to be distributive property. So I get the square root of 2 times the square root of 2 plus 3 square root of 2 times 10 square root of 4, which is just 2. And then I get 3 times the square root of 20. 20 does simplify. 2 and 10, 2 and 5. Again, don't forget about your coefficient that's already outside. 2 is outside, square root of 5. 2 plus 6 times the square root of 5. You cannot put the 2 with that because it doesn't have a square root of 5. It's not a like term. Perimeter of a rectangle, if you wanted to, you could draw a beautiful rectangular picture for this. 2 on the square root of 12, 2 on the square root of 27. Simplify 12 is 2 and 6 and 2 and 3. So this is actually going to be 2 times, this 2 is coming from here. This 2 is coming from here on the square root of 3. 27, if you don't have it memorized, is just 3 times the square root of 3. So I'm going to rewrite that simplified over here. So I have 2. That's coming from here. The 3 is coming from here on the square root of 3. So now I have, move this way a little bit. I wanted to redraw this. I have 6 times the square root of 3 and 4 times the square root of 3. So perimeter means I need to add up all of those, so don't forget the other side. We have like radican, so that's totally possible. So this is going to be 20 on the square root of 3. Simplify number 14, you're going to distribute. If you do not know what 1/4 times 8 is, you can use your calculator or you can cross reduce. So we have a squared on the numerator, a to the 3rd, b to the 1st. You can write this out if you really wanted to. We're left with 1 on the top, 1 over AB. You can also simplify by subtracting, right? We get a negative 1, which means it's going to go in that denominator. 15, this is your flour. Now, this is on the formula chart, okay? This was where we said your denominator became your root index, and everything else became your radicand. That is on your formula chart. So if you needed to, I would definitely look at that. Your denominator is your root index, and then your coefficient, and your numerator. Those become your radicand. Almost done. 16. Notice this is a cube root. Some of you on that last question on your quiz forgot that it was a cube. So if we're going to say 27, oh, well, we did that up there on number 13 earlier. Now we're looking for groups of 3. And I can write out a to the 9th, 6, 7, 8, 9, e to the 6th. Well, look at that. Everything has a group of 3. That means this is rational. So I have 3a to the 3rd power b squared. Because everything matched up. Simplifying here, I'm going to put a 1 on my negative 3. We're just distributing. Okay, this is also on your formula chart. Negative 3 is 3rd power. A to the 4 times 3 is 12. Negative 2 times 3 is a negative 6. Technically, you could leave it like that. It depends on what the answers are. We can write negative 3 cubed a to the 12 over b to the 6. We could even simplify negative 3 cubed. Now, please be careful when you do this, because that is not a positive 27. Negative 3 times negative 3 times negative 3. This is positive 9 times negative 3 is a negative 27. So technically, all of these are possible answers. Last one, explicit formula for the sequence. Again, this is going to be a geometric sequence, so we're dividing by 2. We can't write divided by 2, though. We can write times 1/2. That's our r. Here's our a sub 1. If a sub 1 is 2, and our common ratio is 1/2, we can write a sub n is equal to 2, which is our a sub 1, times 1/2. You could also write 0.5 here, to the n minus 1 power. I hope you do well.